Welcome to the Digital Amateur Television Experimenters Night. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. Do you realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world? Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Yes, well, good evening. This is VK7 OTC with the Digital Amateur Television Evening presentation provided by Reast from the Radio and Electronics Association of Southern Tasmania. I'm Warren, VK7 Whiskey November, and just temporarily stepping in, trying to cover for Justin, who will be in later this evening, but has left the reams with me for tonight. So we'll see how we go, and bear with me as I stumble my way through the studio technology. Well, so first a few announcements to make here. So we'll see. We have to give notice on that people will be able to call in either on R2, the local repeater here at the club rooms, as well as on our YouTube streaming channel. If all going well, I'll be able to see any comments you leave on the chat channel of the YouTube stream. Now, an important reminder here of the ACMA consultation paper on licensing changes. So there's a little bit of time left to get your submissions in, and in fact it is due to this issue that Justin is actually attending an online meeting regarding these changes, and that's why he's presently not here in the studio. Okay. We also have a reminder that it's the last couple of days to get your logs in for the Rosshull Memorial Contest. They are due on before the 19th of February. So do make sure you keep that date in mind. Okay. Also to announce is there is a new version of the software for the WSJT WSJT-X, which is the weak signal narrowband application, and the new version, which is JS, the new version is WSJT-X 2.4.0. This will be, it says here, release candidate up until the 26th of April 21. Previous version being 2.3.0. The general availability is now available as well. Okay, we'll go back to the test pattern for a brief moment, and we might invite one of our guests, Murray, VK7ZMS, who wants to talk to us about some antenna work that he's been doing. So please stand by. Make yourself comfortable here, Murray. And we'll go back to the camera here. Yes, well, in the studio now we have Murray, VK7ZMS, is that correct?
Correct, yes.
Yeah, good evening, Murray.
Thank you.
What have you brought along for us?
I brought along a recycling project.
Yes,
A recycling project. So this is one of many 70 centimetre old ATN yagis that I've collected over the last few years, quite accidentally, just to stop them going to the tip, really. And I've never done anything with them. I can't find any information about the actual design, although it appears that they are a fairly old sort of design where all the elements are pretty much the same length. They put the original director was very close to the driven element, and apparently that was just the way yagis were made before we had software to design them.
Yeah, it looks like it's actually was very sturdy built in its day.
Probably, and it came with good insulators, and you know they had a 1-to-1 balun here, which I've never seen one that survived to this day.
So this is so this is a 1-to-1 balun here.
Yeah,
and
I believe.
Okay, and what's exactly that? Is that an end connector? Is it?
Yeah. This is 70 centimeters. So
it's 70 centimeters. So it was designed and built for the 70 centimeter band.
Yeah. So the plan is to recycle these, and I've just been measuring this and playing with the VK5DJ software, which is readily available online, and it would appear that I can reuse most of these elements, maybe all of them. Some with as little as 3 millimeters of trimming, and basically re-drill the boom and replace them and make a modern design yagi using pretty much all the same gear except the driven element, and we'll use a far different system here. For so you say this was originally a 70 centimeter? Yeah, so it will be still 70 centimeters.
And it will be? Yeah. And what are the changes you're going to...
We're basically going to re-drill the boom and move the elements and change the element lengths to a modern design. Reuse the insulators, reuse the boom, reuse the elements. And to that end, I've instead of these being actually electrically connected to the boom, because as you can see, these bolts go all the way through.
Yes.
And they're electrically connected.
Yeah.
I'll replace them with some stainless steel hardware, and I've got these little. I don't know if you've got the other little. Do you know how to get that happening?
Okay. Yep. We can switch over to that. We'll just go to there like that.
If you put that down on its side,
and So that's the sideways view. It's a little
Yeah.
bit.
I don't know if you can get some more light on that.
Yeah.
You'll sort of be able to see that it's a nice little mushroom-shaped insulator,
Mhm.
and it's
There it is standing up.
and it fits down over the boom. It's got a little round shape where it sits onto the boom at the top, and that'll insulate that from the boom. So we'll be able to use the fully insulated above boom calculations from VK5DJ.
Yeah, it reminds me a little bit of those insulators you use on like the TO3 transistors and things like that.
Yeah, except
it
that
has
it's got that
bit
little
of a longer neck on it.
yeah, and it's got this little radius. It's got this little radius in here. It's where it goes down over the top of the boom. It's a bit hard to show on TV, but you can see it goes down over the top there, and gives a nice good.
So I'm
Good fit.
curious, what makes you want to, I guess, re-drill and resize some of the elements? Are you using a different model for that frequency?
Yes, because we've got no idea what this design was.
Right. Oh, okay. So we don't actually know what. Oh, so this was for 70 centimeters,
It
but a
would have
design
been,
that we were not
But
familiar with.
no.
Yeah.
And having talked to some of the older members of the club, they said, "Yep, it's very common. All the directors are pretty much evenly spaced and all exactly the same length, and that's just how they made Yagis before we had software to calculate and optimize."
And do you plan to use this for portable operation?
Well, a couple of these little short ones. I'll build a 2 and 70 about this long, and they'll be my field day antennas. But I've got quite a few longer ones floating around that might end up as more permanent installations.
The permanent ones, will they be pointing then to particular repeaters?
No, I probably have one maybe pointing at ZL,
Which one is that?
a 70 centimetre one.
On Mount Wellington?
No, to New Zealand.
Oh, to New Zealand.
Yeah.
Yes,
So
okay.
probably one.
ZL, of course.
Yeah, sorry. And one pointing there, and probably one pointing north to pick up any tropo to the Big Island.
Yeah, so you're ready to go when it opens up.
That's it. You know, one of the good things about being in Tassie, you really can get away with those two directions for UHF, VHF. You're not really going to pick up any international DX in any other direction. So
Yeah. Well, that'll certainly be worthwhile keeping an eye on and mentioning when you succeed in making contacts to ZL and also to the north.
yeah, well, yeah. I mean, I've only ever worked into New Zealand once on 70 centimetres and once on 2 metres, which was the same day.
That is pretty good.
But we might be attempting to do that again on tomorrow evening.
Yes, okay.
Hepburn chart's looking very promising, and Rex is planning to attempt a 10 gig from New Zealand to Tasmania from his QTH. And as long as Hepburn holds in there as predicted, I think ZBX is planning to try and do one from Mount Wellington. So,
yeah, okay.
I'm sure we'll have some 70 centimetre gear there for liaison. If there's a duck there and we can't work on 70, well, we won't be getting the 10 gig gear out. Yeah.
No, that sounds really good. Yeah. Oh, well, thank you very much for bringing that in.
No worries, that's my show and tell for the evening.
Quick and easy. Yeah. Well, we look forward to the updates.
Thank you.
Okay. Do you want to send Steve in?
Yes.
Yeah. So, viewers, no comments yet, but we are streaming live on the YouTube channel, and you are watching the Radio and Electronics Association of Southern Tasmania, the digital amateur television presentation for tonight. And our next guest is Steve, VK700, and he has a couple of different items that he's brought along.
Evening, Warren.
Good evening, Steve.
How are you?
Yes, it's a beautiful day today here in Hobart. The weather is
28 degrees.
fantastic.
It was quite a bit warm on the push bike riding home.
Good work. Good work.
Yep.
Yes.
So anyway, I've got a few things in my box.
Okay. Well, what have you brought for us tonight?
Okay, so first item is NanoVNA. Now, we all know what a NanoVNA is, but for those that aren't too familiar, it's a very small device that does an awful lot.
Yep.
So-
I think
So your NanoVNA is an analyzer,
yep.
and it comes with a crappy little piece of cable that is easily damaged, and so the device is quite fragile.
Mm-hmm.
So I thought I'll get hold of a nylon chopping board, and I'll embed into the chopping board the various connectors, which is N connector, PL259 and B and C, that I'm likely to use when I'm mucking around with an antenna.
Yeah.
So that device holds the NanoVNA nice and neat. It just sits in there, and that short cable is now secure and not going to break,
Mm-hmm.
and I can easily unscrew it from there and put it onto whichever other one I want. So that makes it quite a useful device. So having done that, I now have a problem with calibration, because I have to calibrate now at the end of the connectors. So what I've done is I've made up a set of calibration tools out of B and C connectors. So you might want to put these on the overhead just to show people.
Okay. So what we'll do
So
here.
I've calibrated on the B and C connector only, and that's good enough at HF frequencies to use on any of those connectors.
Okay. Now let's see. We want to go to the overhead, which.
Yep.
Oops.
Right?
There we go.
Yep.
Okay. So we've got.
Now, what you're looking at there is a commercial termination tool, which is a 50 ohm terminator from a 10 base T network, if anybody knows what that is.
Yeah, that's basically, it's a 50 ohm one, is
50
it?
ohm coax,
Yeah.
yes. Yep.
Okay, well they're probably the most common ones we know of.
Yep. Yep. That one there is a homemade 75 ohm terminator, which is
Okay.
simply 250 ohm resistors in parallel.
We have a little resistor in the back there.
There's two of them in there.
Oh,
Okay,
yeah.
so it's just in there. It's just clamps on it, and they're just garden variety JCAR resistors. I shouldn't mention that name, but anyway. But it's flat. It's flat to 30 megs, no problems. Now
Yeah.
that one, can you just show the pin end of that one, Warren?
So up this way,
No, the other way up.
the pin end.
The pin end, you'll see that there's no pin in that. So that's
Oh.
my open circuit terminator.
Yes,
Right.
look at that, no pin in there.
No
Yeah.
pin, so that's the open circuit terminator, or
Okay.
test tool, if you want to call it that. And this last one is a short circuit, and it's
Oops.
basically just a B and C connector with the center pin and the outside shorted together.
Yeah, so basically, yeah, just a short between the pin and the back there, soldered up.
So I can now I have calibrated my NanoVNA with a 50 ohm set and with a 75 ohm set. Now, why would I do 75 ohms? Why on earth would I calibrate my VNA to 75 ohms? Especially since the little patch cable that comes with it is 50 ohms. Why would I do 75 ohm termination?
Well, you might be testing 75 ohm cable or so.
I'm testing 75 ohm receiver antennas, which all of my receiver antennas
Yes.
run on RG6 coax.
Okay.
So I'm using 75 ohm
Mhm.
as my receiver system, and so if I want to check an antenna to see if it's working the way I expect it to, I need to test it at 75 ohms. If I put a 50 ohm calibrated NanoVNA on the end of that line, what's going to happen? It's going to look wrong.
Yeah.
So I've just calibrated it up to 75 ohms, and I've stored that in one of the recalls. I don't worry about calibrating it every time I use it, because as I said, from 30 megs down, you'll probably notice it each time you calibrate it, it looks exactly the same as when you just use your one that's stored. Rightio, so I thought that I'd bring along a few other things to show and tell. So this little device, people who will know what that is a, right way up, Airspy HF SDR. So this is an SDR receiver, and you can see that it fits in my hand quite nicely. It does basically DC to 30 megs, and then from 60 megs up to goodness knows where. Can't remember the highest frequency, I don't use it above HF. But I wanted this for using it on 20 metres. That's the only band I'm interested in. That's what I wanted it for. I wanted to use it on the slow scan system that I operate on, which I am currently doing. So I've taken it out of circuit tonight to bring it up here and show it. But this is operating my slow scan system, which is previously running on a regular HF receiver. Now it's running off SDR and working quite well.
This model is some more, I wouldn't say traditional one, but this one's been around a bit longer, has it?
This one's been around, I think, since 2017.
Yeah.
And it has very high specs, has a lot of, let's try again, has a, what's the description? Can't think of the word. But anyway, it has a very wide receiver band. It's receiver bandwidth of 768 kilohertz, which is more than fine for what I want it for. But it has a high dynamic range. That's what I was trying to think of. So it's a very sensitive receiver, according to the specs.
And it's quite heavy too. So it has a very solid metal housing.
Yeah, and you have two connectors on there, one for HF and one for VHF. And it's a matter of remembering which one's which. So if it doesn't work, you've got your antenna connected to the wrong one.
Certainly identical. Are there actually any descriptions on there?
Yes, there is. There's a tiny little H on that one and a tiny little V on that one. That says V and that says H, and there's two little lights in there that are always on, so I don't know why they bother having two lights.
Which are permanently on.
They're permanently on anyways.
Yes, okay. Yeah, with the old trusty reading glasses, I can see here the H and the V.
But it's a nice little receiver.
It's nicely built.
Inexpensive. They're only a couple of $100. So when I say, some of these SDRs, and we're all talking mostly receivers, some transceivers, they can mount into many hundreds of dollars. For around about $250, you've got one of these, and it's that much better than an RTL. The RTLs being $35 or $40, which are very limited in what they can do. So anyway, having done that and got that in circuit, I now no longer have one in the shack to play with. So I thought, I'll buy another one. So I went and bought a HF Discovery, which comes in a box this big. So, and in the box, surprise, surprise, is something that's even smaller. So when you compare the two, the HF Discovery is a much smaller radio, but slightly better specs. It's got better DSP, it's got better prescalers, etc., etc., etc. They still claim a surprisingly wide dynamic range, but one connector. So HF and VHF all on the one connector, so there's nothing to get confused with. As yet I haven't tried it. I'm expecting it to work better than the other one, but probably not well enough for me to necessarily notice. But
now a basic question from me is, having not played with those yet myself, you use an application on the computer, I suppose, to talk to these?
Yes, you need a computer to, because as a receiver, I mean, this is your radio receiver, and there's no speaker, there's no knobs, there's no nothing. It's just an antenna and a USB socket on the other end. It has to be connected to a computer. It has to use appropriate SDR software, and names that come to mind are Linrad, HD SDR, SDR Sharp, which is the one that Airspy recommend because it's their same product, and the other one that I'm using is SDR Console, and the reason I'm using a SDR Console is I like the way they're being developed. I like the development on that, and the fact that you can run multiple receivers within the same instance of receiver, of the software. That attracts my attention. I don't need anything other than that. As I said, I'm only using it in 20 metres, and I'm using it for slow scan. So that will work quite happily with virtual audio cable or a real loopback connection on the outside of the computer. I use both methods, and having a lot of fun with it.
And do the same applications work for each of these devices?
Yes.
Yeah.
They'll work with pretty much anything, especially when you're using something like SDR Console or HD SDR, with a thing called EXTIO. Basically, somebody out there will write a driver to suit almost any piece of hardware, and you can use it with that software. So there's a lot of flexibility around. But I'm not using the EXTIO. I'm using the native Airspy drivers with this, and quite happy with the performance.
No, well, certainly nice as you move up in your hardware. You can continue with the
I'm also conscious of power consumption, because what most people don't realise that the average amateur radio transceiver just sitting there doing nothing is drawing anything up to 50 watts. Doing nothing.
Okay.
Just sitting there listening.
Just
and
listening.
I'm listening 24/7. So to me, if I can cut that 50 watts down to 10 watts or 15 watts or whatever, and these things draw 5 watts maximum.
Yeah.
But the computer draws power as well. So I'm using it with a low-powered computer. You can also set up a server on a Raspberry Pi, and the Raspberry Pi only uses a few watts.
Yeah.
So with a Raspberry Pi, you're using less than 10 watts.
Yeah.
With a lightweight computer running Windows, you can still get away with the 10 watt budget, maybe 15 watts. And as a server, and that's what I'm using it as, a server in the shed, and then in the house I've got other computers hooked up to that doing things, and they're all drawing only 10 or 15 watts. So I've got my power budget well below 50 watts, and I can do more with it. Because a transceiver is receiving on one frequency only. With this, I can receive on slow scan, I can receive on whisper, I can receive on FT8, I can receive on a number of different frequencies all at the same time.
All simultaneously.
Yep. So
fantastic.
as such, I haven't set up a fully operating system, but I have trialled it, and it does work.
Does work. Oh, excellent.
Now, the other thing I've got in my box
Ooh.
is a mint tin.
Yes, the Eclipse.
The Eclipse mint tin. These tins are made of metal, so they make great RF enclosures. This one is designed to fit directly onto that. So it's got BNC to SMA adapters on the end of it. And inside the tin, and it's probably not possible to show this, so I'll have to describe it, is a light bulb and a couple of diodes.
Well, we could try and put it on the close-up camera here.
You'll need your lights if you want to try that.
Okay. Well, look, why don't we... what I'll just do is see if I can turn the torch on this here.
Can't you turn the lights on that?
Yeah. I'm not convinced by those.
Put it over there and see what happens.
So put that in there like that.
Okay, so there's a little bit of light.
A little bit.
So inside there, in between those two connectors, that blob in the middle is a light bulb. And it's not a particularly powerful light bulb, it's only half a watt or 1 watt or something like that. And also in there on the left side there are a couple of diodes. Now the idea here is to protect the receiver from any strong RF. So the antenna comes in the connector that's currently at the bottom of the screen. The signal goes through the light bulb and then goes to the receiver, which is the connector on the top half. And those diodes will clip any high signal levels that come into the receiver. So the receiver won't see anything much higher than it's designed for anyway. And the light bulb will light up if there's enough power present. And I have lit that light bulb up.
Yes.
I have a bad habit of wanting to transmit on the same frequency and the same band that I'm receiving on. And with the antennas aren't terribly far apart. So this is crucial for me to have this, otherwise I would be destroying my Airspy, even though it does reputedly have a very powerful and robust front end. I don't want to test it, so this little device, simple to make, it's just a light bulb and a couple of diodes. The trade-off is that the diodes introduce capacitance to the receiver input, so you may have some issues with sensitivity on weak signals. It certainly doesn't bother signals of any reasonable strength.
So as far as the circuitry goes, so the two diodes I believe would be back to back?
The diodes are in parallel back to back,
so
that they will completely clip an AC waveform.
And they go from the, let's say, the center pin to ground?
To ground, that's right.
And the bulb?
The light bulb is in series between the two connectors.
Is in series, right. Okay.
So between the two connectors. So the signal has to go through the light bulb. The idea being that if the diodes start conducting because of excessive level, the light bulb will become the load.
Become a resistor then.
Becomes the load, it lights up. And when it lights up, of course, its resistance increases.
Yeah. Oh, excellent. Okay, nice piece of work.
And it works.
Yeah.
Like I said, I've lit it up. And I've tested it on strong signals. You can't tell whether it's in circuit or not. I haven't as yet had a chance to test it on weak signals, but I expected I would lose a little bit of signal on the weaker ones, only because of the capacitance that the diodes introduce. So that's it.
Yeah.
That's my show and tell.
Well, gosh, that's very nice. Maybe one evening we can light up the light bulb.
Light up the light bulb.
Have a look inside.
Yeah, no, we'd need to put a dummy light on one side and an antenna receiving a strong signal on the other side. We wouldn't want to transmit directly into this, of course, because the light bulb's not going to handle more than a few watts.
Yeah.
So, you know, that's the thing.
Yeah.
But of course, if there were more than a few watts going into it, then the light bulb would pop and the receiver is still protected.
Yeah, no, and I like the use of the Eclipse tin.
I've got a handful of these. My wife used to use them a lot, used to eat them, and I said, well, give me the tins. And the first one of these I made, I put the connectors on the edge, and I found I couldn't tighten the nuts up, and it just didn't work properly.
Yeah,
I just couldn't keep the nuts tight, and every time I put a connector on and off, they'd fall off. I thought, no, I'll rebuild it. So I just threw that tin away.
Yeah.
Grabbed another tin and put them in on the side, close to the end where the lid is, because that's where I've got to solder. No point putting it down the other end because you can't get to anything. And done them up very tight with a spanner, a pair of pliers. Always got to use a pair of pliers. And now that works really well. So,
oh, excellent. Very good. Oh, well, thank you for all that, Steve.
that's okay.
No, that's good.
Yes, but this is certainly a great device, because when you're in the field, out in the backyard, checking an antenna whether it works, and you're using a NanoVNA, it's a fragile device. When you do something like this, then it's no longer fragile.
Yeah, no, I don't have a VNA myself, but I'm watching people use these on videos and so on. It does become apparent that they're a delicate device, especially the small SMA connectors on them.
Yes,
and you want to connect them to major
and those
cables.
patch leads, and those patch leads as well.
Plus, you want to drive it by touching the screen,
Which you still can. I was told by our illustrious Justin that the NanoVNA was actually quite easy to use in bright sunlight. He's telling a fib. It's extremely difficult to see what's going on. So I recommend doing your antennas on a 30 day.
The truth comes out. Yeah. No, this I can see. You can get a sturdy grip on it and mess around with the heavy cables without.
That's right. These. If you're wondering how I made this, this is basically chopped up. It's a kitchen chopping board, and I've cut it up and screwed the pieces together. So all the screw holes on the back. The only piece I bent was this slightly bent one here.
How did you heat it up to bend?
Heated it up to bend. I expected it to be more flexible, but it was actually quite hard.
Yeah.
Which is the reason why I ended up cutting it up and screwing it all back together again.
Yeah.
But these connectors, they have knurled gripping areas, which you can drill a hole in the plastic and then use a drill press to force them into that hole. Effectively clamps them in place and won't go anywhere.
Okay.
So,
very nice.
Nice and strong. Yeah, use the
Oh, nice piece of work.
Yeah. And it works.
Very good.
Okey-dokey.
Well, you've seen it here first.
Hope so. Rightio.
Good. Okay.
I'll get out of here.
Thank you very much, Steve. Well, just a reminder to our viewers, you are watching the Radio and Electronics Association of Southern Tasmania, the DATV evening, Digital Amateur Television evening. And as far as presentations go, that concludes our list for tonight. So we will be presenting a number of videos now, which will go out on our RF on our RF signal. So we'll be closing down on the broadband streaming in just a minute. So hope you've been able to bear with me for tonight, and there will be a number of things to see next week. We have in the studio here some new monitors here for our work. Well, actually, I'll give you a quick preview now. So we'll just run the camera down here. So these here are our two new monitors. I don't know how far I can flip them over. Not enough that you can see what's happening on the screen, but they are very nice. This one here actually shows us what is going out on our RF and streaming signals, and this one here is for monitoring purposes, so that we can preview what will go out when we switch across. Good. Okay. So we will we'll go back to the VK7 OTC test screen for a minute, and in the meantime get the videos underway.